Hey everybody, it's Dr. Wood, and today I want to talk to you about bias. What is bias? Well, bias is not error. Those are two different terms when we're looking at research here, but bias is going to be a really important thing you want to try to hunt down and make sure that researchers are accounting for in their articles. And so basically, when we say error, that doesn't mean that you screwed up in the test or in the study. Basically, it means the natural variability in the data. But bias is different because bias is basically pushing your numbers one way or another. And it could be totally unintentional. It could be something that is out of the control of the researcher. Sometimes it can be intentional. And so it's always important for researchers to try to think about potential source of bias and try to eliminate those or at least address them wherever possible. So before the experiment starts, what are some ways that bias could sort of influence the experiment unduly? Funding is a big one that I don't think enough people look at. And so basically you want to think about who's funding the study because you may find that it will put if you have a lot of money behind certain types of studies, you may be more likely to see more of that being published. So that kind of influences studies to go, the types of studies you might see if more funding is going towards those particular types of studies. You may also want to think about things like what type of relationship the researchers have with the funders. Maybe those people feel like they have some skin in the game in terms of making sure they show positive results. Anytime you ever see these stories that come out like on CNN or MSNBC or Fox or wherever, they say like, oh, if you eat blueberries, it's going to cure cancer. And you go and you look, and maybe there's some difference in cancer rates between people who ate 4 pounds a day of blueberries versus those that didn't. But then you also see that it's funded by the National Blueberry Council. That's obviously going to be a problem, right? Because again, they are funding that study to show that difference, and oftentimes the interventions that they're paying for may not even be reasonable, right? So when I was reading, they were eating practically a pound of blueberries a day. I think that was a fruit. It's just not reasonable, right? I'm pretty sure my 2-year-old could probably eat a pound of blueberries a day, but not generally feasible for a lot of people. Next up, just the flawed study design, right? So is a comparison even fair to begin with? If you're looking at survival rates in patients with HIV who get this brand new treatment versus placebo, well, that obviously doesn't make ethical sense, but also it's kind of a flawed study design because we know that heart therapy works. We know that it's increases survival. So make sure that it's actually a good, fair comparison in the first place. Selection bias is a really important one too. Groups should basically come from the same general population, and so this is important when you think about randomizations and the process for randomizing people. For instance, if you're randomizing people that come into the ER, you may find that people that come during certain times of day may change, right? So, for instance, if you're only recruiting people that come into the ER during the daytime, because that's when you can actually pay for people to recruit people into the studies, you may be missing a big group of the population that maybe only comes in at, say, 3 o'clock in the morning. So make sure that the group is actually representative of that general population. And then channeling bias is another one where you see that patients should be assigned to groups randomly or at least equitably. But if not, then you may find that you can have undue influence on the results. So for instance, say you're doing a study on an orphan indication. Orphan indications are typically things that affect a very small number of people. You have a really sick patient, and you're like, man, I have this new experimental drug. I really think it'd be life-changing for them. I want to make sure they get into the treatment group and not the placebo group. Well, having that sicker patient in the treatment group may unduly affect the results of the study and say, okay, that patient died. Maybe that's making the drug or the therapy look less effective potentially, right? So again, it should be totally random. So try to take all the human influence out of it. Now, during the experiment, lots of sources of bias can come up here. So, for instance, if you have, say, a provider interviewing a patient and doing a survey, you may find that researchers need to be blinded in order to prevent them from having any kind of undue influence. So, say if you were doing a study on depression, you were comparing a new drug versus placebo, and you were interviewing patients and doing tests on them to see how their depression is doing. If you knew that patient was getting active drug, you may be looking for certain things or maybe asking certain questions different ways in order to skew the results one way or the other. Sometimes this is unconscious, but again, things like blinding can help to prevent that. Okay. Recall bias is a big one. You'll see it with surveys where patients tend to forget things, or they may only really recall really significant things for them. And so this is why it's really good to collect data as early as possible in terms of whatever intervention or outcome you're looking at. Measurement bias is another one where sometimes you can have like mechanical issues that come in into play. So for instance, if you had you're tracking weights of patients and you had one scale that always skewed up, say 2 kilograms, and every single patient that weighed was always skewed up that 2 kilograms versus other scales that didn't do that, that could be a form of measurement bias. And then misclassification bias is an important one in terms of making sure people are trained correctly. So say, for instance, you were doing a study looking at otitis media, and you're doing something with like an actual otic exam. You would want to make sure that everyone who is looking at that eardrum is classifying patients the same exact way. Because if you had 100 different providers, they may call it may say this is infected, this isn't. It could be read many different ways. So that's why you want to train people and make sure they're doing it correctly. So after the experiment, again, you may find that confounders could be influencing your results. You try to deal with those things during the study as much as possible. So having good randomization procedures, making sure that patients are and providers are blinded, things like that. Sometimes you can account for that with statistics, so you can do things like controlling for different variables to see if it's a confounder or not. But ideally, you'd like to get as many of those taken care of within the study design, and then that leaves you to have to do less work with the statistics a little bit later on. And then publication bias is another big one that I think most people don't really think about enough. There's actually a good John Oliver clip you can check out online if you don't mind the little bit of bad language. But the publication bias is basically where negative results are less likely to get published. And that's a shame, because that's really important data too. We need to know the negatives as well as the positives to be able to get the full story. But it's not really exciting if you run a whole experiment and get your hopes up and then it's negative. You may not even want to try to get that published in the first place, right? And again, not only that, but also not all journals are created equal. So you may find that there are certain journals to where they seem legitimate, but they ask you to pay a certain amount of money in order to get published. That's usually a pretty big red flag, because they may have less strict review processes, and may not even do the peer review process. They may be more likely to publish something just because you paid money for it. So again, look at the journal that you're getting things from. If it's JAMA or the Lancet or something like that, it's probably a pretty good journal, but there's a lot of smaller ones where we may not realize that it can be an issue. So as an example, the big one that we use in toxicology is called Clinical Toxicology. It's a very well reputed article or journal, but there is the Journal of Clinical Toxicology, and that is not a good one. And so it's very easy to see that difference there. The names are so similar, it could be very easy to get mixed up if you didn't know what you're looking for. So just be cautious. And again, when we talk about impact factors a little bit later on, that'll help you determine how good of a journal you're actually looking at is. So that's it for this section. If you have any questions, let me know, and I'll talk to you soon. Thanks a lot. Bye.